What does it cost to teach a machine to think? Long before generative AI became a household name, this question was up in the air for many decades. In science fiction, the dangers of autonomous, self-thinking machines has been a topic of fascination since as early as the 20th century. Culturally, mistrust circulates around artificial intelligence, with many arguing that the cost of AI creation includes the loss of autonomy, as well as estrangement from authentic community interaction. From the short stories of Isaac Asimov to the modern-day film adaptations of The Matrix and Ex Machina, the popular genre of AI takeover presents interesting ideas about the impact of human-machine interaction. Many of these popular narratives occur alongside a backdrop of environmental ruin. In many cases, humans turn to and rely on artificial intelligence after the destruction of our own planet. There is a cinematic quality in contrasting sleek technological performance with harsh, barely familiar landscapes. Oftentimes missing from this discourse, however, is the inextricable link between artificial intelligence and the environment, especially in a time of rapidly worsening climate change and resource depletion. In reality, every time a powerful AI model is created and trained, it costs us, but not in the way you might imagine. With each new iteration of artificial intelligence, the training process not only mimics human knowledge, but also takes from the environment. Generative AI models consume electricity, utilize water, and emit electronic waste before it even answers a single question. And this only scratches the surface of the potential environmental damage of this rapidly changing technology. Welcome to Earthtech, your gateway to exploring how technology is transforming environmental science and shaping a sustainable future. I'm your host, Michelle Liu, and I'm passionate about creating a future where innovation uplifts communities and protects our planet. You're listening to Episode 1, What Does It Cost to Teach a Machine to Think?, an exploration of the environmental consequences of training generative AI. To start this discussion, I think we need to begin by defining what exactly generative AI is, which is a smaller subfield of artificial intelligence, capable of creating content and ideas, whether that be art, music, conversation, or programming, of course, based on patterns learned from existing human-made sources. Generative AI has already left its mark on various industries, from the development of personalized chatbots and large language models to automated suggestion systems within healthcare to the creation of entertainment and advertising media. As for discourse surrounding this meteoric rise in generative AI technology, coined as the AI gold rush by Forbes, it's important to note the distinction between generative AI and numerous other forms of artificial intelligence. I think it's very easy to group AI as one singular monolith. However, it's important to make these distinctions because different types of AI can have varying effects on ourselves and our environment. For instance, predictive AI, another subcategory, distinguishes itself from generative AI because it forecasts potential outcomes based on typically more targeted and historical data. An emergent and powerful type of generative AI in commercial use today is based on transformers. Transformers are a special type of neural network architecture, capable of processing user input to generate output, typically used in commercial applications. Widely utilized platforms like GPT, Claude, Gemini, Sora, and DALL-E are all based on these transformer architectures. The training requirements, computational power, and implementation of these transformer-based models, steps that drastically heightened the visibility of AI services in recent years, simultaneously depend on vast amounts of energy to sustain. So let's dive into this topic. In order for a generative AI system to comprehend any question or complete a task, models like GPT-4 go through a very specific training process. This begins with large-scale data collection, as developers systematically gather diverse datasets, training the server on human language patterns, historical occurrences, informational articles, the list goes on. Next, the model adjusts parameters, or internal variables that allow the model to recognize patterns and make predictions. In a multifunctional transformer model, the amount of parameters utilized can range from hundreds of thousands to the billions. So this process, of course, demands a tremendous amount of energy. For most, generative AI models require staggering levels of electricity to train. Data centers, temperature-controlled facilities that support the infrastructure needed for training and deploying AI, require a power density more energy-intensive than traditional computing counterparts. And this is paraphrasing Noman Bashir, Computing and Climate Impact Fellow at the MIT Climate and Sustainability Consortium. Furthermore, the process of cooling also demands water supply. Liquid cooling is still the most popular method for maintaining steady temperatures while training generative models, and this requires fresh water. However, current usable fresh water takes up a mere 0.5% of Earth's available water resources. The reason for this is because salt water leaves behind corrosive mineral residues that can degrade elements of AI hardware, such as GPUs, after evaporative cooling, which results in the continued depletion of freshwater supplies, sometimes from municipal sources. Without regulation, the continued expansion of data centers especially threaten areas already facing water scarcity. Of course, quantifying climate impact can be a difficult task, especially when applied to such an emergent technology like generative AI. According to a 2019 study conducted at the University of Massachusetts Amherst, the carbon dioxide emissions needed for training a transformer model with neural architecture measured 626,155 pounds, compared to the 36,156 pounds expended by the average American individual in a lifetime. In more understandable terms, the one-time training carbon expenditure of this model equaled that of over 17 Americans for the course of their entire lives, of course, within the bounds of the study. In a 2021 research initiative, scientists from Google and UC Berkeley estimated that the training process of GPT-3 consumed 1,287 megawatt-hours of electricity. In other words, the power required to run 120 average US homes for an entire year. And in a separate 2025 study, the amount of fresh water evaporated to train GPT-3 amounted to over 700,000 liters of water. That's nearly 3 million cups of water fit for drinking. So it's easy to identify a few limiting factors of these metrics. First of all, it's actually quite hard to determine the actual climate consequences with a singular metric. Water usage, carbon emissions, and electric waste are often only pieces of a grander puzzle. Furthermore, discourse surrounding AI's impact on the climate often disregards what happens after deployment. There's one issue of energy consumption per search, a difficult value to measure due to limited research and company transparency on the inference or real-time usage process in relation to climate impact. Furthermore, generative AI may contribute to the initiatives of companies that disservice the environment. For instance, a generative AI system that pushes fast fashion retailers to users via advertising may be far more detrimental in its ability to cause environmental damage past the training process. There's also another factor to account. AI is still constantly evolving. Data centers are increasing in size, complexity, and availability. And as this demand rises, the simultaneous advancement of sustainable energy still struggles to match the pace of AI, leaving data centers reliant on non-renewable energy sources or fossil fuels. I think it's very easy to place the burden of AI's environmental impact on ourselves. In fact, the need for responsible use has somewhat made its way into opinion pieces and articles and even research. Now, responsible usage may look differently per individual. This might take on the form of digital minimalism, where you try to stop using AI in its entirety, or limit the queries that could be accomplished by ourselves or by a simple search. People may also choose to stop supporting AI extensions added to popular apps, or they might limit or cut out the use of video and image generation services, especially when used recreationally. However, within this conversation, there are also larger systemic issues at play. First of all, there are currently few regulations being placed on energy grids and data centers, although these are truly the hubs that are producing more generative AI systems. Furthermore, there's a systematic lack of research and funding for measuring AI's environmental impact, especially in determining a clear metric for measuring AI energy use, for looking at inference, and for setting an energy standard in these times of environmental emergency. Currently, there are also commercial expansions of AI without consideration of the target audience or of its detrimental environmental impact. Finally, there is a lack of transparency from AI companies. A 2023 Stanford study named the Foundational Model Transparency Index, or FMTI, examined 10 major AI-using corporations, including Google, Meta, and OpenAI. Researchers examined 100 detailed data points used to assess transparency, with no company receiving a passing score. Particularly, scores were lower during the training phase, as companies did not release the resources used to analyze data and to create these generative models. So while the propagation of generative AI may seem endless and technologically promising, we must stop ourselves and question real-world cost. Past the spectacle of human imagination, as envisioned in science fiction and pop culture, training artificial intelligence has a far more tangible environmental effect, directly tied to how our planet sustains our basic needs. So whether we attempt to mitigate AI's environmental harms through supporting sustainability-focused research, holding AI services accountable, or demanding greater transparency in AI's energy use, we must act now to ensure that technology doesn't come at the expense of our climate's future. Thank you for tuning in to today's episode of Earthtech. We truly appreciate listeners like you who are passionate about the intersection between sustainability and innovation. Join us next time for an episode on how the solar punk movement may shape a new generation of environmental technology.